questo progetto ha dato veramente la possibilità di andare al di là, di fare un passo in più.
Per conoscere il mondo delle telecomunicazioni che fa parte della nostra vita quotidiana.
Iniziare delle collaborazioni con altre università.
Ha consentito appunto una sinergia molto forte fra persone diverse.
Per la prima volta mi trovo davvero a collaborare con altri ricercatori, altri esperti.
Riusciamo ad avere una comunicazione immediata tra di noi.
Un movimento proprio bello, proprio perché è un movimento dinamico.
Quindi sicuramente l'opportunità maggiore è stata la collaborazione a livello nazionale e anche interdisciplinare.
È parecchio utile dal punto di vista del rendere l'avanzamento del progetto come qualcosa di fluido e naturale.
Quando si fanno le cose insieme, ci si muove molto più veloci.
Superando le barriere geografiche o anche quelle sociali.
Nel 2025 muoversi veloci anche nel mondo della scienza è abbastanza importante.
C'è bisogno di ripartire appunto, questa è l'idea di Restart, convogliando tutte queste forze sul futuro delle telecomunicazioni.
Buongiorno e benvenuti a tutti, io sono Antonio Capone, iniziamo la plenaria di Restart qui a Napoli. Just for non-Italian speaking, the very first part will be in Italian, then we will immediately switch to English. Benvenuti a tutti, do la parola al professor Daniele Riccio, rappresentante dell'organizzazione locale e che comincio a ringraziare per tutto il lavoro fatto per l'organizzazione. Grazie.
Allora, buongiorno a tutti. Allora, il padrone di casa, il professore Andrea Prota, presidente della Scuola Politecnica e delle Scienze di Base. Grazie.
Grazie, buongiorno a tutti. Ringrazio Daniele Riccio, Antonio Odice, tutti voi che avete organizzato qui a Napoli questo incontro. Sono il padrone di casa, diciamo, è stato generoso perché questo è lo spazio di tutti noi, è l'icona, diciamo, dell'ingegneria a Napoli, perché è nota come la torre di ingegneria, questo edificio. Fu progettato da Luigi Cosenza, architetto, e tra l'altro è anche vincolato dalla sovrintendenza, e quindi con questo vi dico che se quando arrivate sotto vedete qualche sistemazione temporanea, con tutti noi stiamo lottando con la sovrintendenza, perché diciamo nell'ammodernamento dei tempi questi spazi così belli e aperti non sono più gestibili. Abbiamo un grandissimo problema di sistemazione temporanea di homeless, e quindi vorremmo chiudere questo spazio per renderlo più fruibile anche ai nostri studenti in maniera sicura. Sono molto lieto che voi siate qui stamattina e vi do il benvenuto come presidente della scuola nell'epoca post Gelmini, almeno qui, perché poi in funzione, diciamo, degli atenei da qualche parte ho visto che ci sono ancora quelle che si chiamano facoltà. Qui questa era l'aula magna della facoltà di ingegneria, ma ora non abbiamo più facoltà, abbiamo dipartimenti. Alla Federico II ne abbiamo 26, 11 di questi, quindi il 40% come dipartimenti ma anche come docenti. Abbiamo adesso circa 3.200 docenti, quindi il 40% è nei nostri 11 dipartimenti che sono raccolti in questa scuola Politecnica delle Scienze di Base, quindi ingegneria, che ha 5 dipartimenti, e uno di questi è il dipartimento promotore di questa iniziativa, il Dieti, a cui afferiscono Daniele e Antonio. Uno è architettura, e poi abbiamo i 5 dipartimenti del Collegio di Scienze, quindi matematica, fisica, biologia, chimica e geologia. Do questo benvenuto con piacere, ma tra un attimo poi mi fermo, perché tra l'altro conosco bene questi progetti. Sono il presidente della fondazione Return, che è quella dei rischi, e quindi ho apprezzato molto, mi compiaccio per l'iniziativa. Sappiamo che in questo scorcio finale di progetti, ne parlavo prima con il vostro presidente, siamo tutti alle prese con portare a termine al meglio questo progetto, e poi nel frattempo il Ministero ci ha dato questo compito questa sfida sul DR 307, che in parallelo è abbastanza deflagrante, ma la parte di disseminazione è molto importante. Sono molto interessato a partecipare ai lavori, e ringrazio Daniele che mi ha invitato, perché questo format è interessantissimo. Il challenge è la disseminazione, di farla anche con i nostri giovani. Mi piace molto l'idea che questo evento si tenga senza creare interruzioni di servizio della sede, quindi i nostri studenti saranno qui, noi speriamo che vadano anche in questa sala o nell'altra per ascoltare i lavori. È molto interessante anche l'organizzazione delle presentazioni dei progetti, questa cosa molto dinamica che vi aiuterà a far conoscere all'esterno ancora di più gli esiti del progetto e i benefici che porteranno al Paese. Quindi vi ringrazio molto, sarò un po' con voi a sprazzi, e Buon lavoro, grazie.
Allora, buongiorno, ci dovrebbe essere qualche slide piene di formule, per forza. Un elettromagnetico ve le riempie sempre di formule, quindi io devo presentarvi l'organizzazione, quindi naturalmente partirò con le solite equazioni di Maxwell e ve le faccio un po' vedere. Allora, quando poi mi hanno chiesto dall'ufficio stampa qualcosa, gli ho mandato le formule, ho detto, professore, questa cosa non va bene. Allora ho girato tutto e me ne sono uscito fuori con questo non è un convegno, ha fatto subito pensare a Magritte, Alice nel Paese delle Meraviglie, insomma, quindi ha entusiasmato. In realtà veramente questo non è un convegno, se ci pensiamo bene, è una cosa diversa, che richiede una partecipazione diversa da parte di tutti quanti. Io provo a fare un ragionamento che coinvolge tutti quanti noi. Questo ragionamento è di che ci occupiamo, ho dovuto spiegarlo. Allora, le telecomunicazioni cosa sono? A me è riuscito semplice dire come fanno, cioè le telecomunicazioni plasmano. Che plasmano? Scienza e tecnologia in maniera tale che si abbiano delle cose nuove, interessanti e permettano di trasmettere a distanza. Che vuol dire plasmare scienza e tecnologia? Beh, pensate la storia, no? Trasmettiamo un testo, dei suoni, delle immagini, delle realtà aumentata, dei pensieri, delle emozioni, delle sensazioni, andando avanti le cose cambiano. Per questo motivo le telecomunicazioni sono innovative, per forza. Nessuno usa un sistema di comunicazione di 5 anni fa. Tutti voi sarete venuti con un sistema di trasporto di 5 anni fa, non vi ha fatto specie, fosse anche un aereo. Nessuno sarebbe un telefono di 5 anni fa. Soprattutto noi comunichiamo molto di più in un modo che 5 anni fa non immaginavamo nemmeno. Ergo, fra 5 anni comunicheremo in un modo che non immaginiamo nemmeno, e anche noi. E allora hanno bisogno di tantissima innovazione. Su questo settore non ci possiamo fermare. In più, altra caratteristica, dovendola spiegare all'ufficio stampa, le telecomunicazioni migliorano. Non tanto le telecomunicazioni stesse, non hanno tanta valenza per sé, migliorano gli altri settori. Pensate cosa può essere o può diventare la telemedicina con le telecomunicazioni, o l'aerospazio. Quindi è lì che si vede il vero valore delle telecomunicazioni del futuro, fare delle ricadute verso l'esterno, e Andrea cominciava a dirvelo. Questa cosa che state facendo è interessante per noi. Allora, l'idea che le telecomunicazioni possano migliorare è un altro elemento. C'è un altro aspetto da considerare. Se è tutto innovativo, se migliorano, se tutto cambia, le telecomunicazioni richiedono investimenti. Per forza, perché se la tecnologia di 3 anni fa non la uso più e se l'asset economico che avevo 3 anni fa non è più valido, devo rimettermi in gioco. Quindi devo investire continuamente. 2 aspetti positivi. Se si investe continuamente bisogna innovare e allora serve la scienza in senso ampio, non solo l'ingegneria dove siamo noi oggi, ma le scienze di base, le scienze umane, perché poi sono gli uomini i fruitori di questa cosa. E quindi serve la scienza. Secondo, questi investimenti non sono sempre costosissimi e quindi se io oggi non sono in una nicchia di mercato, se non sono un asset tecnologico forte, posso diventarlo fra 3 anni. Basta che intercetto la nuova tecnologia, il nuovo business principale. Quindi con le telecomunicazioni noi possiamo migliorare gli altri servizi e possiamo anche creare investimenti, o dobbiamo creare investimenti, perché possiamo spostare l'attenzione. Federico II produce una montagna di laureati. Il fatto che siano bravissimi e possano andare nel mondo ci entusiasma. Dar loro una chance per restare dove vogliono sarebbe una grande cosa. Questo credo che oggi, che è un problema di Federico II, diventerà di tutte le università. Anzi, Federico II forse avrà ancora sempre studenti, altre realtà forse meno. Conclusione. Se queste cose sono vere, le telecomunicazioni devono cominciare a comunicare cosa sono e devono fare in modo che questa comunicazione produca novità e anche qualcosa di bello. Quindi questo convegno tende a essere un esercizio. Questa è la live demo 0 di Restart. Non è un convegno in senso proprio, provo a farvelo vedere. Noi cerchiamo di dimostrare che queste cose che ho detto sono vere attraverso questa attuazione. Innanzitutto siamo nella facoltà, ve l'ha detto Andrea, cioè qui intorno ci sono gli studenti, queste sono le nostre aule, quindi continuiamo a vivere qua dentro. Noi lavoriamo principalmente in queste due sale qui disegnate. Chi siamo? Siamo quelli di Restart, non siamo un convegno, non abbiamo gli steward, non abbiamo le hostess, e quindi siamo noi, ragazzi che vedete che non sono scritto staff, sono i nostri RTDA, siamo noi che lavoriamo, quindi questa è una nostra azione, dobbiamo capire se riusciamo a presentare innanzitutto a noi stessi quello che facciamo in modo innovativo. Lo facciamo in questa sala, che però ha una novità, vedete laggiù, 2 telecamere lì, un'altra qua facciamo delle presentazioni tipo talk, quindi queste cose vengono registrate, restano un oggetto in patrimonio di Restart. Qui dentro, live, si registreranno degli oggetti che da noi resteranno. Quindi in questo momento avviene qualcosa, noi qui stiamo lavorando, non è un convegno. Naturalmente la visione di queste cose è doppia, sia da parte di chi parla, come era l'immagine prima, sia da parte vostra, e vedete che lì quella telecamera dice che ogni tanto potreste essere in qualche modo persone che intervengono, perché quella telecamera è in grado di riprendervi. È chiaro che la presentazione non è più statica, non c'è la persona di qua che parla e gli altri che sentono. Siccome stiamo lavorando insieme, dobbiamo interagire. Non solo qui, in un'altra sala questa immagine si replica perché siamo iscritti 330, questa sala ne contiene 250, e nell'altra sala chiederemo, quando qui siamo in pieno, di dover andare, e comunque ci andranno gli studenti del nostro corso di laurea, quindi possono assistere da lì quello che noi facciamo qua dentro. La vita della facoltà prosegue giorno per giorno. Questa è la sala interviste, altra azione. Vedete che qui sono iniziati tutti i verbi che noi adoperiamo. Intervistare è un'altra azione che facciamo. Chi presenta qui giù e chiunque voglia o abbia da dire nella biblioteca libri storici troverà una sala attrezzata per un'intervista. La comunicazione del Restart farà questa intervista e questo è un altro tipo di oggetti che ci resta. Avremo queste interviste che potremo montare e che resteranno con noi sempre. Lavori in corso. Questa è i lavori in corso fatta venerdì della sala esposizione demo che trovate, insomma, se uscite da qui e fate la diagonale siete alla sala esposizione demo. La biblioteca per i libri storici è al piano di sopra, ma chiedete ai ragazzi dello staff e vi guideranno. Allora, nella diagonale di là arrivate in questa sala. Quasi emblematicamente questa era la sala disegno e adesso è diventata la sala in cui esponiamo le nostre cose. Sono esposizioni live. Ogni progetto strutturale o focused ha un monitor, ci si può collegare, ha 4 o 2 banchetti, una zona circostante. Ci sono delle live e delle demo che invece sono più grandi e che girano per la stanza. Lì un'ora al mattino, un'ora al pomeriggio per entrambi i giorni andiamo, ci saranno qualche persona che controllerà. Vi prego di indossare sempre il cartellino per motivi di sicurezza, cioè dobbiamo sapere dove siamo, chi siamo, eccetera, eccetera. Quindi lì dentro avvengono delle presentazioni live. Live non solo vuol dire che c'è un monitor e non c'è un poster, che le persone che vanno lì fanno parte di quel live e la camera che vedete qui andrà lì a riprendere queste fasi. Quindi anche quella è un'azione viva di lavoro nostra, interna, per produrre materiale per noi. Questa è una sala consiglio, riunioni, faremo le riunioni con il CNIT, le riunioni a distanza. Chiunque abbia bisogno di una sala per collegarsi o per riunirsi con un'azienda all'interno della sua università, con la sede base, l'abbiamo attrezzata come serve. Questa è un'altra operazione di lavoro, riunirsi, un altro verbo. Siamo qui per lavorare, lo facciamo in questo modo. Vedete, questo non è un convegno. Ora, torniamo a questa presentazione che è abbastanza classica. A noi va bene, tutto sommato ci fa piacere perché poi l'immagine della Skyline di Napoli va benissimo. In realtà appunto non è un convegno, qui lavoriamo, siete tutti attivi, tutti presenti su questa cosa, portate il contributo perché questo è necessario, migliorate il sistema, se andate là, fate, toccate, possibilmente non rompete, ma insomma cercate di interagire con questo oggetto perché tutti lo dobbiamo migliorare. Questo oggetto può funzionare o non funzionare. Abbiamo preso molti rischi, ma d'altra parte se le telecomunicazioni non cambiano il loro modo di comunicare, chi lo fa? Anzi gli altri dovrebbero prendere spunto e quasi quasi dire questo appunto è anche il laboratorio zero di Restart, un nuovo modo di comunicare se stessi. Quindi fatelo. La parte di organizzazione può non funzionare quella telecamera, poi il catering, del catering e del lunch non vi dico niente, tanto non vi devo insegnare come si trovano. Può non funzionare tutto. Non è un problema perché questo è il contenitore e noi non siamo contenitore soltanto, noi siamo contenuto, quindi noi abbiamo preparato il contenitore e potranno andare. È come se avessimo fatto il campo di calcio qui accanto e poteva anche non essere zollato, ma poi sono i giocatori che vanno in campo, quelli che parlano di qui e quelli che ascoltano di lì, che si giocano la partita e quindi tocca a voi vincervi lo scudetto. Grazie per essere qui. Buona giornata.
Buongiorno. Buongiorno a tutti, grazie per essere venuti. Mi fa molto piacere che ci siano 370 iscritti, Daniele, che è un numero ragguardevole, quindi la nostra comunità è molto ben rappresentata. E io voglio iniziare ringraziando preventivamente l'organizzazione, lo rifaremo poi alla fine dei 3 giorni. Qui non ci sono tutti i nomi, è solo una cosa che mi hanno passato stamattina, ma ringraziamo dall'inizio i nostri colleghi che si sono spesi per questo non convegno, non solo di Napoli ma anche di CNIT e di Restart, la comunicazione Restart che è arrivata qui con difficoltà ieri causa guasti treni, e anche le persone di CNIT, dell'agenzia Stile Libero e Anastasia che sta qui dietro. La seconda cosa che voglio dirvi è raccomandarvi di partecipare al 3° giorno, che è un evento che si chiama Build Your Career, dedicato specialmente alle 300 persone assunte nel corso del programma Restart. È un invito che va non solo ai giovani colleghi, ma soprattutto ai loro tutori, che non si facciano scrupoli nel caldeggiare e nel finanziare questa cosa se necessario. Quindi ci teniamo davvero molto a che le 300 persone assunte partecipano a questo evento, anche per sentire da loro delle idee, perché io continuo a ripetere che sono loro la nuova generazione del nostro settore, quindi è bene sentire da loro cosa dobbiamo fare. Io vado a ripetere alcune cose che ho detto in altri eventi, perché è bene che tutti quanti siamo consci di da dove siamo partiti e perché abbiamo chiamato questo programma Restart. Quindi alcune cose le ripeto, ma è bene che tutti quanti partiamo dallo stesso livello di conoscenza. Siamo partiti da una grave crisi delle telecomunicazioni, ma non delle telecomunicazioni in quanto settore, ma delle telecomunicazioni in quanto operatori classici e del relativo indotto. Perché questo? In realtà non tanto per ragioni tecniche, ma per ragioni sia politiche che di organizzazione finanziaria, che di regolazione. C'è un'eccessiva competizione sui costi, abbiamo troppi operatori che si competono fortemente tra loro, c'è una competizione non giusta verso i cosiddetti hyperscaler, verso gli OTT, verso i grandi 7 americani, ma non solo, anche cinesi. Pensate un solo esempio, che se i nostri operatori potessero seguire le stesse regole che seguono Google, Amazon, eccetera, potrebbero regalarci la connettività a internet e ai cellulari e ci guadagnerebbero anche. Questo solo per darvi un'idea. I costi dello spettro sono molto elevati e dovranno essere ripagati tra poco, i costi di energia aumentano e la net neutralità, che peraltro è applicata solamente in Europa, costituisce un impedimento allo sviluppo, ad esempio, di 5G. Va detto però, e qui noi possiamo cominciare a fare la differenza, che gli operatori sono stati colpevoli di poca innovazione, hanno lasciato ampi spazi non coperti che sono stati riempiti dagli hyperscaler di cui sopra. Qui voi che siete tecnici possiamo fare dei nomi di cose specifiche, ad esempio il multicast, il broadcast, la differenziazione dei servizi, la mobilità di rete, l'indirizzamento, il processamento in rete, il cambio del modello di comunicazione. Gli operatori hanno inseguito su questo le innovazioni, le idee portate dagli altri. Questo ha causato il fatto che molti player hanno entrato nel mercato nostro, il mercato delle reti. Infatti non li chiamiamo più over the top, ma li chiamiamo hyperscaler perché stanno dentro la rete. E quindi abbiamo questi signori Alphabet, Meta, Netflix, Apple, Amazon, Microsoft e poi anche i cinesi che entrano nella rete. E cosa fanno? Quindi non danno solo le applicazioni, ma ad esempio danno connettività. Internet, voi sapete, è una rete di reti, almeno questo abbiamo studiato. Oggi invece gli hyperscaler si connettono direttamente dalle loro reti di partenza a tutte le altre reti del mondo, senza passare attraverso altri operatori. Gli hyperscaler arrivano oggi all'80% di internet direttamente. Questo significa che il link che parte dalla California è di Google e arriva fino alla rete di accesso italiana, senza passare da nient'altro. quindi un'occupazione della parte di rete. Non solo, la cosiddetta orma off-net degli hyperscaler è enormemente aumentata. Cosa significa? Che i loro server e le loro funzionalità sono situate nelle reti anche di accesso degli operatori. Quindi ancora una volta possono far concorrenza partendo dalle reti stesse. Le CDN, che non sono degli operatori classici, trattano ormai quasi tutto il traffico di utente e i primi 6 hyperscaler generano e gestiscono l'85% del traffico delle reti mobili, in cui i ricavi sono circa il 40% per pubblicità. Ecco, questo è il quadro in cui gli operatori classici si devono muovere. A questo aggiungiamo una storica avversione al rischio dell'Europa. Basta vedere il capitale dedicato agli investimenti dei venture capitalist negli Stati Uniti e quello dell'Italia. Ci sono ordini di grandezza di differenza. E quando riusciamo ad avere delle idee in Europa sono comprate dai capitalisti, dai venture capitalist americani. Il sistema bancario non aiuta. Un esempio banale, le banche devono dare una garanzia quando fanno operazioni immobiliari di 1 su 5, quindi devono mettere da parte un quinto del capitale. Nell'investimento di rischio tecnologico devono mettere una garanzia di 1 a 1. E questo limita fortemente anche gli investimenti nella tecnologia. I risultati: una frammentazione di internet. Non è più una rete, ma sono tante reti logiche, ognuna che fa riferimento al proprio hyperscaler, oltre alla frammentazione geopolitica. C'è un digital divide che non è solo sulla connettività, ma è sulle piattaforme. Lì è il vero regno, no? Non si può fare nulla senza una piattaforma di sviluppo degli hyperscaler. Quindi c'è un service divide più che un digital divide, o meglio non solo. E ci sono meno opportunità per la ricerca aperta, perché se non abbiamo a che fare con questi signori, sappiamo meno di ciò che avviene, no? Se uno fa routing satellitare, dovrebbe sapere bene cosa fa Starlink, e non tutto si sa di quello che fa Starlink. La frammentazione opera anche a livello applicativo. Ci sono ormai poche piattaforme che generano quasi tutto il traffico. Siamo tornati un po' indietro da questo punto di vista, no? Siamo partiti dai 3 canali Rai, siamo andati a una cosa molto distribuita, siamo tornati ai 3 canali YouTube e quant'altro. E in prospettiva le cose peggioreranno con l'AI e con il video sempre più percentualmente quota parte del traffico. E quindi quella che sembra, questa è la rete delle strade romane, quella che sembra internet, e quindi sembra una rete paritaria in cui tutti quanti svolgono un ruolo, in realtà è la rete delle strade romane, in cui Roma giocava un ruolo predominante. E quindi quella che sembra una rete di reti, in realtà sono 5 reti, logicamente, oggi. Inoltre, il peso finanziario si è spostato. Vedete che mentre gli operatori classici hanno continuato a guadagnare in modo costante, gli altri sono aumentati e quindi è molto difficile finanziare nuovi investimenti in infrastruttura. Ancora non si sanno bene le cause, ma il recente blocco dei radar nel nord-ovest è causato da un malfunzionamento di un operatore di telecomunicazioni. E se non si investe in questa infrastruttura, e qui io vedo un pericolo, perché Fibercop diventa un quasi monopolista, e se non c'è un modo di garantire che faccia investimenti sulla rete, la rete non terrà il passo delle innovazioni. Tutto questo paradossalmente in un mondo in cui invece di soldi ce ne sono a bizzeffe, perché le applicazioni generano tantissimi soldi e perché comunque il mercato globale, chiamiamolo di internet per capirci, cresce del 15% l'anno. Quindi le risorse ci stanno, è solo che non vanno più agli operatori classici, vanno da altre parti. E anche noi dovremmo, poi magari voi più giovani non lo siete, non avete questo bias, dovreste pensare non in termini di operatori classici, ma in termini di hyperscaler. Queste sono le più recenti slide della preparazione di FP10, del prossimo framework program della Commissione europea, e quindi fa vedere che ancora una volta ci sono opportunità di trilioni nelle varie applicazioni. Rimedi sistemici su cui si sta un po' lavorando, l'Europa si sta un po' smuovendo, e cioè una regolazione che sia non più ex ante ma ex post, che sia giusta e che sia leggera, perché questa regolazione che abbiamo noi in Europa penalizza fortemente i nostri attori. Rivedere le regole della net neutrality, cercare di espandere l'ambito della comunità verso gli strati alti, salvaguardando sempre le nostre radici, ma applicandoci agli strati alti, e, lo ripetiamo da tempo, cercare di avere delle piattaforme europee, delle telco cloud company, perché altrimenti, come proviamo a uscire da questo impasse, ricaschiamo perché non possiamo fare a meno di queste piattaforme. C'è un esempio di successo che è Airbus, che è avvenuto tanti anni fa. Era difficile pensare a un concorrente di Boeing, no? Però Airbus ci è riuscita e ha superato Boeing, quindi si può fare. Che abbiamo fatto in questi 2 anni e mezzo? Avete fatto ottima ricerca, alcune missioni sono andate bene, altre meno. Io continuo a ripetere che la parte veramente trasformativa di questo programma sono le missioni, è come il PNRR. La gente non ci pensa molto, ma il PNRR prevedeva tutta una serie di riforme trasversali della giustizia, della burocrazia, degli appalti, perché quelle sono trasformative. I soldi per costruire i ponti o le strade o le scuole vanno bene, però poi finiscono, mentre invece la parte trasformativa resta, ed è quella che cambia il paese e che dovrebbe cambiare il settore. La Challenge Zero, che sarà presentata da Antonio, riguarda invece, secondo me, un buon esempio di quello che si può fare in questo ambito. Cosa possiamo ancora fare? Abbiamo messo le fondamenta per questo settore, per avere una nuova fase dello sviluppo delle telecomunicazioni, cercando di uscire dal collo di bottiglia degli operatori. Questo dobbiamo fare noi come comunità di ricerca, perché se restiamo lì, restiamo ingolfati in un settore che sembra ormai fermo. Invece dobbiamo andare oltre. Dobbiamo sfruttare i risultati del lavoro fatto, dobbiamo cercare di mantenere internet aperta, perché la ricerca non si può fare se non c'è un ambiente aperto, e anche l'innovazione e la ricerca, perché anche questi, se continuano a tenere tutto chiuso, alla fine andranno a sbattere, perché le idee vengono dalle comunità aperte. Quindi alcuni punti specifici, e concludo con queste slide veloci: cercare di rendere strutturali quello che abbiamo fatto in Restart in termini organizzativi, mantenere il finanziamento, dirò qualcosa su questo sull'ultima slide, creare una partnership, un consorzio pubblico-privato. Abbiamo il CNIT, è il caso di mantenere la fondazione Restart? Io ho detto più volte che secondo me è il caso se c'è una componente privata, e questa sarebbe molto utile e ci stiamo lavorando. Sviluppare tecnologie sovrane e affidabili e resilienti, con focus sulle reti 5G, sul cloud e sull'edge, sulla cyber security, sulla protezione delle infrastrutture, e ridurre la dipendenza da tecnologica esterna. Integrare la rete con settori verticali, soluzioni ibride tra rete fissa, mobile, satellite e IoT, digitalizzare i settori. È lì che c'è il mercato più grande ed è lì che non ci esprimiamo abbastanza come settore. E quindi questa cosa va avanti da 10 anni forse, no? I trasporti, l'energia, tutto quanto, lì ci dobbiamo impegnare. Sempre facendo il nostro mestiere, mica ci mettiamo a fare altro, no? Non è che dobbiamo costruire macchine, ma dobbiamo fare le tecnologie per i trasporti. Le reti private è un altro grande settore su cui noi non lavoriamo abbastanza, legato anche alla legislazione, ma comunque si potrebbe fare anche usando le licenze degli operatori. Ma anche qui ci vuole proattività, perché, scusate, sto cercando di andare indietro. Per favore mi rimettete. Ho sbagliato. Ecco, dobbiamo essere proattivi verso la pubblica amministrazione e verso quelli che costruiscono le applicazioni nel proporre soluzioni di rete. Dedicarci, come abbiamo fatto ancora, alla parte di formazione, quello è il nostro mestiere, quindi su questo diciamo non c'è molto, siamo abbastanza confidenti che ci riusciremo, ma è l'ultimo punto, l'ha già detto Daniele, cercare di mantenere i talenti formati, occuparci di trasferimento tecnologico e di crescita industriale, anche da un punto di vista imprenditoriale, cercare di avere una visione strategica nazionale, e questo lo potremo fare nei prossimi programmi, e di avere una presenza europea, anche nella standardizzazione e con un ruolo più concertato nei programmi europei. continuare su questo fatto che il pubblico non sa bene che cosa siano le telecomunicazioni e quali siano le opportunità che si possono avere da questo settore, e quindi continuare a lavorare sul marchio. E infine cominciare a pensare a quello che l'Europa pensa si debba fare sul prossimo programma quadro, e come vedete si parla di una network computing platform come aggregatore della tecnologia europea, che ha 3 grandi pilastri, che sono il cloud, l'intelligenza artificiale e il quantum, con le tecnologie, vedete la radio, il software, il service provision, le reti ottiche, i satelliti, la sicurezza, la sostenibilità, con l'elettronica sotto. Questo è il quadro che sarà proposto nei prossimi mesi per FP10, e qui dovremo trovare il nostro spazio. Sappiamo tutti che siamo in un settore strategico, ed è quindi tempo di consolidare, far crescere e trasformare quello da cui siamo partiti. Ripeto, il nome Restart. Su cosa stiamo lavorando, e concludo. Ci sono 2 programmi, si chiamavano PON, adesso hanno un nome un po' diverso, e noi come Restart siamo impegnati in 2 proposte, una in collaborazione col partenariato SEDIX che si occupa di cyber security, e un altro in collaborazione con il partenariato che fa Quantum e con quello che fa HPC. Sono quindi 2 programmi a mio parere molto interessanti, sia per il finanziamento, ma anche perché ci mettono in contatto con altre comunità di grande importanza, una di cyber security e una di Quantum e HPC. Lì potremmo, se vogliamo, avere un ruolo e anche imparare, nonché insegnare agli altri. È previsto inoltre, è uscito nella finanziaria ultima, un contributo governativo ai partenariati estesi, che vale circa 300 milioni per gli anni 27 e 28, e che sarà assegnato in base ai KPI che raggiungerà questo programma. Il decreto è pubblico, l'ho mandato al CDA, lo manderemo al Consiglio Scientifico, ne parleremo il più presto possibile, perché questi KPI possiamo migliorarli, dobbiamo migliorarli, per cercare di poter avere questo finanziamento. Quindi su questo chiedo davvero l'impegno dei colleghi, perché in questi 6 mesi che rimangono dobbiamo portare su dei KPI su cui siamo ancora giù. Ci sarà una plenaria finale a dicembre a Roma, in cui dobbiamo cercare di avere gli stakeholder del settore. Possiamo fare un libro, se ci interessa, che metta assieme l'enorme massa di contributi scientifici prodotta, un'enciclopedia possiamo fare forse, che da quello non ci sono problemi. E non ve lo dico nemmeno, spendete i soldi che avete, Antonio dice rendicontateli, state attenti che se non li rendicontate e li spendete poi ce li mettete voi, ma spendeteli, perché indovinate un po' qual è il primo KPI per avere nuovi soldi? Vi saluto e vi ringrazio e buon convegno.
We switch to English now, and we start the program of the meeting. As usual, I will give you a very brief overview of an update of our research mission, which is the main one. As Nicola said, we are doing pretty well. Here are the scientific and communication KPIs that have been updated in the last days. So we are doing very well in terms of scientific papers. We are also contributing a lot in terms of communication. We have a very successful website. We are also very active on social networks. We are also doing well in the other cross-project initiative that Nicola mentioned. Some of the grand challenges already produced and published some of the white papers. Some are the preliminary versions, others are already final versions. So we will have at the end for all the clusters of grand challenges that we have a tangible result that will show the cross-project activities that have been done. One of these is the one of Challenge Zero that, again, Nicola was mentioning. There will be a presentation by me in the afternoon and a panel discussion on this important aspect of the future evolution of the ecosystem of telecommunications. The projects are doing well, and they are already working on the final demos and POCs. They have planned for their activities. The full list of demos and POCs that we have include 110 items. So a very huge experimental effort that we are doing, and many of these will be available in the exhibition area that is on the other side of this building. I invite you to visit this area. There will be 4 one-hour slots for visiting the area, but most of the demos will be available during the whole day. We are also doing other transversal initiatives, and in particular, one is pretty successful. We started this tutorials series on telecommunications. So we already delivered 27 tutorials, and there are 7 more that are already scheduled until the end of July. There are many others that ask me to propose some new tutorials, and we will update with new tutorials the program in September. Coming to the program of today and tomorrow, we decided this time to have high-level TED-style talks, 14 in total. They will have a duration of maximum 15 minutes, and you will have at least 10 minutes for asking questions. So don't be shy. Ask questions to the speakers at the end of the presentation. We will have 10 live demos presented here in plenary, and as I was saying, more than 100 contributions presented in the project exhibition area. Then we will have in the afternoon the panel on the future of telecommunication that I was mentioning before. Again, I want to once again I want to invite you also to attend the event on July the 2nd. This is dedicated to young researchers and PhD students. There will be 1 inspirational talk, very interesting, 3 panel discussions involving the young fellows and also some more senior guys regarding the industries in particular for describing the career opportunities, and many, of course, networking opportunities during the break and the lunch. Here is the agenda that we have for today. So probably you already have a copy. So I will not spend time to present you all the presentations and activities that we have, and I will just give you some recommendations for the speakers. Stay on schedule. We didn't start very well, but we will try to catch up. And for the speakers of the TED-style talks, if you want to use a radio microphone instead of staying here at the podium, you have to go to the technician's corner a few minutes before starting. Okay? So thanks a lot. And one final important recommendation. This is a tradition of our plenary meetings. We will have an awarding of the best contribution of the projects. Poster and demos and whatever will be presented in the demo area for the projects. Using this QR code that will also be available in the exhibition area, you will be able to vote for your preferred contribution presented by the project. You can do so going and visiting the demo area. So at the end, tomorrow afternoon, we will award the best contributions also this time. Thank you for your attention. Great. So we can now start with the program with the first talk. So I invite here Davide Darderi, University of Bologna, that will deliver the first TED-style talk. The title is Wave Processing Over the Air. Can analog retrieve in a digital-driven era? Davide, the floor is yours. Thank you.
Thank you, Antonio, for inviting me. Good morning to everybody. Well, so this guy is Claude Shannon. Most of you know that in 1948, he published a landmark paper. And in particular, this paper has been a revolution in perhaps one of the main revolutions in the last century, establishing the bit as the fundamental unit to measure, communicate, and compute information. So working with bits give us flexibility, is universal, is semantic agnostic. That means basically we can transmit information without taking care about the meaning of the message we want to transmit. So before this paper, the information processing was mainly analog. And after this paper, basically, the digital revolution started. And today, in particular, for what regard the wireless communication systems, we are moving the border between what we do in the digital domain and the analog domain closer and closer to the antenna. So thanks to the, for instance, software-defined radio. So today the world is digital, actually, as you know. But what are the lessons we learned, let's say, in the last 25, 30 years in communication system? So the answer is clear. No way. We need to deploy as much as antenna as possible. So we need a massive deployment of antenna. Massive MIMO, extremely large antenna arrays, distributed MIMO, XL MIMO, etc., are keywords that today resonate within our community. So the deployment of the massive deployment of antenna is necessary to achieve high data rates, high capacity in the network, to extend the coverage, etc. So we are moving from a scenario in which we have base stations equipped with a few antennas, 4G, for instance. Now we are in 5G with a base station with around 100 antennas. And likely in the next generation, 6G, we expect to break the limit of 1,000 of antenna per base station. So basically, one order of magnitude increase of the number of antennas for each generation. So this is quite challenging because this means a computational burden in the digital processing, the availability of a lot of RF chain, which are energy hungry. So it seems that today technology, full digital hybrid technology, is not scalable as a number of antenna increases. And then we also expect some sustainability issues. So there is the need for a paradigm change. One possibility, perhaps one which is very fascinating, is ask nature to do the job for us. For instance, we can imagine to move part of the digital processing directly to the electromagnetic domain. For instance, by exploiting physics law to perform processing over the air, directly over the air. Basically, what we aim is to find the right balance between what we do in the analog domain and what we do in the digital domain in order to improve the performance, but at the same time to make networks sustainable. So one paradigm we are working on is smart radio environments. So today, all digital wireless communication networks are based on the following paradigm. So basically, we sense the environment. So the environment for us is an input, and then we try to match the network to the environment. So to optimize the network to the environment. So in smart radio environments, instead, we allow the environment to be changed, for instance, by deploying specific technology, and I'm going to show you later, in order so that we can shape how the environment reacts to the electromagnetic wave. So basically, we have soft-defined environments. So in this way, we expect to, let's say, put the environment inside the optimization loop of wireless network design. So we don't optimize only the transmitter or receiver, but we optimize also the environment. So in this direction, let's see some innovations that has been, let's say, presented in the restart. So one is smart skin. So you can imagine a smart skin, a sort of electromagnetic sheet you can bend around the pole on the street, so that it changes the way the propagation takes place, so that we can extend the coverage. For instance, we can reduce the interference and so on. And this structure is passive, so we don't need any energy, let's say, to work with this. So we don't need to head the base stations to, say, increase the coverage. Another fascinating technology is a sort of smart glass. So you can imagine your window with this kind of electromagnetic smart glass. Whose purpose is to capture energy from outside and put it inside, so in order to extend the coverage of indoor environments. So this is one of the main issues in today, you say, wireless systems. And this can be made in a smart way, so that we can facilitate the electromagnetic wave, so without increasing the transmitter power for some signals and reject others, interference, for instance. Another fascinating idea, again borrowed from nature, is the metaprism. So this is what you see here is a classical optical prism. So you know that the optical prism, you have the white light, and when the white light impinging the prism, so that the components of the light, different colors, are spread in an angle domain. Well, so the metaprism mimics this behavior at the radio frequency, so that you can use this kind of structure, metaprism, you can deploy it in environment, for instance, to cope with the non-line of sight conditions, so in areas where we have obstacles. And instead of changing the metaprism in order to change the reflection of the signal, for instance, to follow the target, the user, you just change the property of the signal. You change the color of the signal, and then automatically you change the way the signal is reflected. Reconfigurable intelligent surfaces are perhaps one of the main technology enabling the smart radio environment. So basically, the main difference with respect to what we have seen before is that here we can change dynamically the way these electromagnetic, let's say, sheets behave, in order to facilitate to change the environment. And let me just mention a couple of nice technologies that have been developed within Restart. One is a wrist based on liquid crystal at Terrace. So basically, liquid crystal are the same technology you have in your watch in order to show the digits. You know, instead here, this kind of structure reflects the electromagnetic wave and dynamically. Okay. And another technology is based on plasma discharges. So this is very, let's say, novel technologies. Another possibility is to make RIS energy autonomous. So obviously, if you want to change the property of the RIS, you need some energy for the controller. Well, so you can capture this energy from the same signal you want to modify. So you have an impinging electromagnetic wave you want to reflect on somehow, but and then you can take harvest the energy from this signal to supply the power, the controller. Or imagine that we have already electromagnetic waves from other services, Wi-Fi, TV, broadcast, and so on. Well, so you can recycle these waves, for instance, during the reflection of RIS, to embed data from a particular sensor, for instance, a low-power device. So again, this without adding new signals, new energy in the environment. Finally, another interesting solution is if we want to reduce the digital burden I mentioned before in the base station, then you can imagine to put, for instance, this kind of metasurfaces in a stacked way, so that when the signal emitted by the base station go through these different layers, it is changed a little bit, and at the end we get the final desired function without computing it before in the digital domain. Okay. The main advantage is that this is almost passive structure, so low energy consumption, and at the same time we work at the speed of light, actually. So let me conclude with the final, let's say, more visionary scenario. So this is a classical propagation scenario. So we might have a transmitter, and the electromagnetic waves undergo some reflections, the tree, buildings, and so on. We have multipaths, we have random phenomena, and then at the end we have a linear combination. So all this stuff are from physics, so are for free. Okay. Well, so if you think about this, so these are basically can be considered as the building blocks for a neural network. In addition also to the structure I mentioned before. So you can imagine this, all the network as a neural network that can learn, take advantage of the law of physics, and so the network will become smarter. We can reduce the digital burden, and also we can go beyond Shannon. So while here, for instance, the target could not be to transmit a bit with a low probability of error, but to transmit the meaning. So having a sort of goal-oriented communication, exploiting what nature offers us. So make the network smarter and more sustainable. So that concludes my talk. Thank you for your attention.
Thank you, Davide. Very interesting. So it's time for questions to Davide. Yes.
Davide, first of all, congratulations for your very interesting presentation. The last slide is really a groundbreaking for me. It's really groundbreaking because it's really focused a novel concept. But my question is, what's the degree of reconfigurability of this kind of analogic processing? Because you know that the software radio that is operating baseband is fully reconfigurable via software. Is this kind of smart environment so reconfigurable by software, or are there some bottlenecks? There's still some bottlenecks in this frame, in this perspective.
Thank you, Claudio, for your question. Obviously, there is no free lunch. Okay, so that you lose something in flexibility. So you are not so flexible as a computer and everything in the digital domain. But I think that the key word is to find the right balance between what you do in the digital domain. So you can obviously eliminate digital. Obviously, it would be crazy. But finding the good balance between what we do in the digital domain and what you do in the electromagnetic domain by taking into account the limitations of electromagnetic computing, which also is related to the size of the device, depends on the geometry and other things, but also taking into account the energy consumption, the latency, because working in the electromagnetic domain, you reduce a lot of latency. So at the end of the story, what you have to do is to find the best trade-off according to the specific application you have in mind, in what you do in one domain or another on the second domain. Yeah, thank you.
Thank you. Other questions? We are going up and up in the frequencies, right? So is this something that can facilitate this transition to analog processing, or can create more problems because of the accuracy that you need to have?
I would say, apart from the technology, let's say, limitation that with the years can be overcome. So I think that going up with the frequency, so you gain more degree of freedom. because you can have electrically large devices, electromagnetic devices which are small in size. And also another important aspect is that you can also enable the working in the near field propagation scenario, which offer a new degree of freedom in both in communication and the localization. I think this is the one what we can gain by working at high frequencies.
So you mentioned also energy consumption.
Yeah.
Is this one of the advantages of using these technologies, right? I mean, what's the order of magnitude in the energy saving that you can have?
Yes, it's difficult to give a general answer, but imagine that, for instance, the stacking intelligent metal surface I mentioned before, so all the elements are passive. So the only energy you need is just to change the configuration. So you spend some energy to change the configuration, but the entire processing is basically passive because they are just scatterers, basically passive scatterers. So imagine to do, for instance, electromagnetic MIMO precoder, which means that you have to perform several matrix multiplication in this domain. So you can avoid it by obtaining the same result in the electromagnetic domain.
So basically, the energy consumption is only for the reconfigurability part, not for the
exactly,
processing.
Which is much less than.
Other questions?
A quick question. Hi, Davide. Congratulations on your talk. Just a doubt. How realistic is the total passivity of all these, devices? I mean, you demand so much of them, which is hard to think that passivity, even with energy harvesting, is guaranteed. And if they are not, what's the difference with relays? That's a fundamental question I have.
Obviously, I think that this is one solution. It's not the solution for everything. So it may happen that in some scenario, it would be more convenient to have, for instance, smart relays with some active parts. Whereas in other scenario, if you want, for instance, I don't know, industrial scenario, when you want to work with the hundred of sensors, in that case, a passive, semi-passive solution would be better. So it depends on the application. So that means I think that the future will be a mix of different technologies, some active, some passive. And then what we have to do is to find what is the best, let's say, combination of this technology according to the application. Yeah.
Is that if you try, for example, to use RISs to undertake sensing around the corner, well, the attenuation is so strong that you gain very little. And on top of that, you must be so close by to the scattering point that you are in a near field region. And so the amount of information you have to gather is huge. So it's just, a doubt that came at top of my mind out of some studies I undertook. Thanks a lot.
Thank you.
Other questions for Davide? We will have another talk on analog processing in the domain of optical devices, right? Integrated optical. Do you see synergies between radio and optical in this specific aspect?
For sure, because in the optical field, some of these things are already a reality since several, decades, I would say. So that I think that some ideas from optical devices can be also borrowed and put down, frequency for terahertz or even below. Yeah, for sure. There's some synergies. In fact, for instance, the stack intelligent metal surfaces, the original idea comes from optics, not from microwave devices. Yeah.
Thank you. Another question for Davide? No, okay, so we will now take the break. There is the coffee break on the other room on the right. You enter, exit from this door and then go to the right. We will reconvene here at 11:20 and we will start sharp with the next talk. Thank you. Okay. So, welcome back. The next TED-style talk will be given by Michela Meo, Politecnico di Torino, and the title is Sharing for Resilience. Michela, please.
Okay, thank you, Antonio. Okay, welcome to this session. Okay, so what if, while I'm giving this presentation, there's a blackout? Now, suddenly, you cannot see the slides. You cannot hear my voice, of course, because the mic goes off. Even worse, the air conditioning stopped working. And even much worse, you have to stop reading your emails. The train, yeah, is another proof. Actually, that was another reason, but that's a good point. Okay, so, and then if you are on your way here, you are probably checking your directions on your mobile through the maps, and then there's the blackout, and you are completely lost in what for you is the middle of nowhere. And then maybe you are like discussing something or working or making an important decision or giving a lecture or whatever you are doing, you are working, there's a blackout and you have to stop working. And then maybe you need to buy something. And again, if there is a blackout, you cannot buy stuff. And I don't know you, but probably you do not have cash in your pockets anymore. So that's basically what happens. It's a bit annoying imagining that you cannot rely on communication services. It's actually even scaring. Now, think what people in Spain and Portugal have lived on April the 28th this year. So, you know, you were reading the news for sure. There was this very big event, this very big blackout. What do they call in Spanish? The apagón. I really like this word, the apagón. And then what happened is actually that at 12:33, there were 5 seconds of a power drop in a substation in Granada. And then the substation disconnected from the power grid. And then there was the very well-known avalanche effect. And in only 30 seconds, the whole peninsula, Spain and Portugal, they were in blackout. It took them more than 12 hours to restore the stuff. So in Portugal, the situation was back to normal around midnight. In Spain, it was back to normal at 4 in the morning of the following day. This costed the life of 8 people and 1.6 billion of euros. Now, people were indeed also very scared because they didn't have access to communication services. So this is an image of the railway station in Madrid during the apagón. And then people, they cannot access the internet to know what's going on. They cannot talk to their people. And there's no announcement on the loudspeaker because there's no electricity. And also the screens are black. Actually, one of the main costs was that they had to rescue 35,000 people that were blocked in trains, indeed, in the middle of nowhere. And they had to go there and rescue them. Then in the cities, the police had hard work in directing traffic because traffic lights were off, and so it was a mess. And then people were scared because they didn't have access to information, so they started to stock goods because they were scared. Now, of course, this is a very big event, and luckily they are not so common, not so frequent. At the same time, the events that create discontinuities in communication services are more frequent than what we think. According to the European Union Agency for Cybersecurity, in this report about from data on 2022, there was in European telecoms 155 major incidents, meaning important disconnection of large areas of the infrastructure, for a total of more than 11,000 million user hours, where user hours is a product between the number of people, of users that are affected, and the duration in hours of the event. And actually, the causes, of course, they are not only power outages. There are, in general, more than 70% of system failures, which means, indeed, power outages, but also hardware failure, software bugs, or stuff like that. There are 15% of human errors. Now, we can assume that maybe in the near future, with AI, automatic system, better control, maybe this number might go down. But there is also a 6% of malicious actions, which might grow instead. And it might grow because there are several scenarios that envision the possibility that new terrorism would use communication services to attack critical infrastructures, which are communication services themselves, but maybe the power grid, or maybe transportation systems, or the health system also. Okay, so this is a scenario for outages in general, for disconnection of services. And now, in the same report, if you give a look into which parts of the infrastructure were affected by these events, you would realize that the mobile is the most fragile. And the reason why it is the most fragile is because it's more difficult to protect the access. So even during the big blackout in Spain and Portugal, during the apagón, actually the core network continued working because there was redundancy in communication infrastructure in the devices. There was redundancy in terms of energy generation, but not on the access. So people were disconnected mainly because the access was failing. And it was failing because creating redundancy on the access or protecting the access with some backup battery supply systems is costly because there are so many nodes that it means that the investments become huge. In some situations, it's even difficult to deploy additional stuff, say on rooftops, or maybe for environmental reasons, you just cannot add some more stuff. So putting all things together, what we are claiming is that we have a problem of resilience. We have a problem of resilience because we are relying, for most of our activities, we are relying on communication services, but our networks, our service provisioning is not resilient to unexpected events, it's not resilient end-to-end. In particular, the access is failing. So here the claim is that while we are deploying and creating and innovating with our technologies and our solutions, we should always try to keep in mind resilience. Okay, we should keep in mind the resilience. Now, what is the solution that we want to propose as a way to increase resilience, to improve resilience? What we wanted to propose is the idea of using concepts based on sharing. What it is, this idea is that we should use new concept of sharing of the available resources in a given area which is affected by an incident, so that we can actually provide a longer lifetime to our services. So more practically, what are these resources that we can share? Well, of course, communication resources, so radio resources, and energy. We can share them, try to collect all that we have in that area and put them in a pool and use them, optimizing the usage so that the network lasts longer. We can also put in the loop user cooperation. And then, of course, in order to put together resources, include user cooperation, we would need to develop smart management, smart algorithms that can optimize this concept of sharing the usage of these resources and user cooperation. So that's the key idea. Now, let me show you practically some of the things that could be done. So years ago, now we are talking about the access for the reason I mentioned before. So years ago, we basically had in mind that different operators would have different infrastructures also on the access. Here we have the blue and the red operators, and they are like managing and running their own infrastructure up to the very end. Now, we are already used to site sharing. In site sharing, that it is very common today, you basically would have a third party which is managing the site, and then it would host the equipment of the two operators, the blue and the red one. And then by managing the site, it can somehow optimize the management indeed. So for example, it can deploy a backup battery system so that in case of power outages, it can run the equipment of the two operators. This is already something that it is used. We can go a little bit farther into this sharing concept and introduce network sharing. So instead of doing what we are today doing, what we could do is to switch off the equipment of one operator. In this example, the blue operator. We keep on running the infrastructure of the red operator. And of course, the red operator would also carry the traffic of the subscribers of the other operator. And the advantage of doing this is that with your backup battery system, you would have a network which lasts longer. Of course, the capacity is lower, yes, fine, but still the network can live, basically can double its lifetime because you have half the equipment to be powered. And then we can even extend this a little bit further. So assume that we are in a situation of network sharing, and at some point you run out of energy. So your backup system discharged and you cannot power the access anymore. Now, what you can do is introduce energy sharing together with user cooperation. So, for example, you can retrieve some additional energy from the users that have their own electrical vehicle in the area. You would give them in return some sort of reward, some incentive of some sort, and then they can provide with their energy, they can provide some additional powering for the access. Of course, you could do the same with energy communities. So we know that energy communities are becoming more and more popular. In that cases, you would have groups of users of the power grid in this case, that would have their own local generators like solar panels or maybe small wind turbine, and they would have batteries as well. And then when needed, for some reward, with some incentive, they might help you in running your access network. User cooperation is needed in this sharing the energy. It can also be needed because you would have to request to your users to reduce their demand for traffic. Reduce their demand for traffic, meaning that the capacity that of course is smaller than usual would be enough for running the important services that you have in that moment. So up to this point, we were looking into, say, a site. Of course, we can imagine to extend this to an area. So assume that this sketch is basically the coverage of the blue and the red operators we were looking into before. And they would have coverage in the same area with different technologies. So we would also have cells of different size. And at some point, there is a blackout. So this area is affected by one of the issues that we were previously mentioning. Now, if this is the case, what you can do is start by doing network sharing, meaning that you switch off the infrastructure of one operator, keep the other one on, would serve all the users in the area with, of course, using better the limited energy which is available in the area. And then, as I said, you can go even farther towards energy sharing using the local energy which is available so that you extend the lifetime of your network. And then you could even switch off some of the technologies so that you would sort of leave a sort of a minimum coverage, like a skeleton of the coverage, which of course would have limited capacity, but at the same time would allow you to have basic services. And the good thing is that you can do this with optimal strategies, and now we are very good in creating new algorithms that are smart algorithms that can optimize the usage of resources, and you can actually provide a service which is a service of resilience. Now, I would, as a very last thing, I would like to show you just some results. Here we are applying only the concept of network sharing, and we are assuming that in different hours of the day, we would have a failure, like a blackout. And then we would have a backup battery, and instead of using it for the two operators that are in the same site, we would use the battery for powering only the equipment of one operator. And then what you can see is that in the green part, we basically are capable of doubling the lifetime of the network with no losses. So 100% of the time, the capacity is enough. So you double the lifetime of the network without any reduction in the quality of service. Of course, because during nighttime, you don't need much capacity. Now, during the peak hour, which is the red part, of course, you need more capacity. So in that case, you manage not to have losses while you are doubling the lifetime of the network. You manage not to have losses, something about 30% of the time. In the other time slots, what you have to do is basically to ask the users their cooperation by reducing their traffic, so that you would end up only serving the most important traffic that you have. So then just to summarize, we are relying in most of our activities on communication services. But our communication infrastructures, they are not as resilient as they should, given the usage we are doing nowadays of communication services. So we need to work more on resilience. And sharing is a feasible, but I would like to add also cheap and effective way to resilience. So thank you.
Thank you, Michela. Very interesting. Michela is also the PI of one of our focused projects, R4R, which is dedicated to this kind of technologies, in particular energy efficiency. Questions? So we also have a microphone in the upper part of the room, so in case you have questions, it will be Victoria that will lend you the microphone.
Michela, thank you for your very interesting presentation. In my opinion, the problem of the resilience is related to the fact that we are dealing with very complex systems, having many single point of failures. So if only one of these points is impaired, all the system collapses. Do you think that the approach of the approach where you share the resources, where you're trying to balance the load between different nodes, can solve the problem at the root of the vulnerability, that is the presence of too many single point of failures?
Oh, that's a very good point indeed. I definitely agree with you. And indeed, one of the reasons why we have so many incidents, and one of the reasons why still, despite the effort we are making, actually they are not working as we expect, is because of what you said. Indeed, the data that I was showing, they somehow confirm what you have in mind. The core network, since it is more important, more critical, it is more protected than the access. So the claim here is that, of course, sharing will not solve your problems. And of course, what you have in mind is extremely important. The fact to smooth out the composition of the different several components of your end-to-end service. That's true. At the same time, today, my claim is that today the most fragile part is the access. And while we were trying to do stuff on the core, because it's more critical, because of course, if you have a problem there, it's affecting a lot of users, we are not doing as much as we should on the access. And then if you have the core that works, but you cannot access the services, it's the same stuff, right? At the end, for you, it's the same. You cannot really use it. But it's a very good point, indeed. We should change the way in which we design our technologies.
Diversity, substantially.
Absolutely.
And the sharing goes toward the direction of the diversity.
I do agree. At the same time, if you want, the claim here is, look, there are resources, there is redundancy, and there is some diversity, but we are not using it as much as we could. If you want, this is a claim here.
Thank you.
Other questions for Michela? Yes.
Thank you very much, Michela. The other thing that you can do traditionally with sharing, besides improving resilience, is decrease the redundancy, the duplication of infrastructure, so as to reduce the cost. So is there an inherent conflict between these two things, and how do you think about managing that? Thank you.
Thanks, Francesco, for noticing this. Actually, that's absolutely true. Indeed, if I have to tell you, we arrived to this, work starting from cost reduction and sustainability, because there are several periods, like I was showing the night time. During nighttime, you have more capacity than needed, and you pay for it in terms of energy, in terms of running that thing, and you don't need it. You don't need it for the service you're providing. So it's absolutely true. By sharing, you can also reduce cost. And by the way, this goes also a little bit in the direction of what Nicola was mentioning in the opening this morning, that actually you should start, putting things together in general and try to make like a critical mass effort also in this part. Because you are also spending a lot, for example, on the access, and at the end, if you want, in a sense, the revenues are not coming from that part anymore. So cost reduction is useful for sustainability, is also useful for like a business case, if you want.
Other questions? You mentioned at the beginning the example of the blackout in Spain and Portugal, right? One of the possible reasons for that problem was the inefficient support of the distributed generation that they have in the network. I had the opportunity to discuss with some colleagues, experts of these networks, and basically they said that, well, in other parts of Europe, in particular in Italy, we do have an efficient network because we have the telecommunication infrastructure supporting the smart grid, right? So somehow our infrastructure is also fundamental for the management of the energy distribution grid. How do you see the opportunities to have those synergies also for powering on the network that is fundamental for keeping the rest of the grid on?
Yeah, that's also a very good point. First, there are some analysts about the big blackout in Spain and Portugal that think that part of the problem was the data collecting system that was the one in Granada that I was previously mentioning, that at some point, according to some, because they are not really 100% sure what really happened, at some point, it might be that the data, like the measures that you are doing to control the power grid, was failing, and then for protection reasons, the substation started, to disconnect from the power grid.
Disconnecting also generation. That's a problem.
And the other thing is what I mentioned about the malicious users, like the malicious attack, the new terrorism might want to use the communication infrastructure in support to the power grid to harm the power grid, which is a critical infrastructure. All this said, of course, the more we are good in making the power grid smart and resilient, the better will be also on the energy side. So I don't see it in contradiction. Indeed, as you know, one of the problems of energy communities, which they are really pushed, is the capability of smooth their interaction with the power grid. So there's a lot of room also for us as, telecommunication engineering in trying to find good solutions also for the management of the power grid.
Thank you. Any other last question for Michela? No. So let's thank Michela again.
Thank you.
So the next speaker is Professor Sergio Barbarossa, University of Rome, La Sapienza. Another very interesting topic. The title is Semantic and Task-Oriented Communications. We discussed a lot. What is the I don't know, Michela, hai finito? Ah, ce l'hai in mano il giraslide? Ah, vuoi il microfono? Ok.
Thank you, Antonio. Okay, maybe so that I can move, I prefer this one. Okay, so a brief summary of what I'm going to present. First of all, I will give a context. You know, there is no single definition of semantic communications today, so at least to have an idea of different approaches to this topic. And then I will directly go to the principles that for us are driving the whole concept of semantic communication, which is based on a semantic formulation of the information bottleneck. And then I will show some results, and I will mention the semantic alignment problem, motivating where does it come from. Okay, so context. Well, first of all, we could start from the theory of mind, which is a theory that comes from neuroscience, cognitive science, psychology, if you want, which says very simply something like this. When we talk to each other, in our mind, we build a model of what we have in front of us. This happens all the time. For example, now I'm talking to you, even though I may not know most of you, but in my mind, I have a model that says that maybe you are interested in telecommunications, we can speak Italian, we can speak English, etc. So I modulate my language depending on the model that I build in my brain about you. Then the second point is the second approach to this area is so-called joint source and channel coding. This is a very old problem in information theory. This is the well-known separation theorem from Shannon, but that theorem holds true only when we deal with infinite length code words. So people using deep neural networks today show important advantages in doing the joint source channel coding operation exploiting deep neural networks, properly trained, also taking into account the channel between source and destination. Then there is contrastive learning for habilitating the knowledge transfer. And finally, the approach that exploits generative AI to build these semantic communication techniques, which is primarily what we are doing, what I'm going to talk about. Now, think about conventional approach to communications. Typically, we started for communication human to human, okay? And then we know very well that in our brains, we have a very sophisticated knowledge representation system, which is our brain, that, by the way, works with a very high energy efficiency, consumes very low energy, and still is capable of doing amazing things. Now, when we move to the next scenario where we are having communication human to human, human to machines, machine to machines, etc., we want to build an efficient knowledge representation also in the machines, which is what people are doing in AI. You know, there are so many models, but still they are not very efficient because they consume a lot of energy. They have to be trained properly, etc. So, and most of all, if we, look at the near future, going towards 6G, AI native networks is becoming, a hot area of research. Then, in this context, we are really thinking about distributing knowledge across the many actors composing this network. And the actors, again, are devices, humans, robots, machines, etc. And then we can think something like this. We can split communication in two phases. One, which can be done offline, where we share knowledge. The second one is online. So, for example, in a not too distant future, imagine this talk today, In Naples, you could have uploaded the digital twin of myself yesterday night offline, and then today I'm staying in my house in Rome. I transmit at a very low bit rate, but here, exploiting the digital twin with the low bit rate data coming from Rome, you can in principle reconstruct a very sophisticated Sergio talking to you, maybe a hologram like the one we are going to see in the exhibition part. And then you see, it's like you are splitting two different things. One can be done offline, the other online. Now, the problem then becomes, how can we represent knowledge in a very efficient way? Generative models provide different mechanisms with different complexity, different accuracies, and so on, to represent knowledge. So this is why we want to rely on generative models to design semantic communication systems. By the way, Restart came at the right time, because if I think when we wrote the proposal almost 3 years ago, at that time semantic communications was really not a hot topic. If we look at the papers, these numbers that I just took from IEEE, so it's not a very accurate estimation, still we can see that during these 3 years of Restart, the number of papers in the IEEE on semantic communications increased a lot. So this maybe abused picture that I showed also other times. We have these famous 3 levels of communication: the technical level, which is the one we are used to work with. Then we have the semantic level and the effectiveness level. But here, we can implement what I mentioned before about the theory of mind. The more the source knows what the destination knows, the less it needs to say. Assuming that you know a lot, I can reduce all I have to say, because I know that you can reconstruct it properly in your mind. Now, when we deal with communications, typically we are worried about the distortion that we might have. We might have distortions at the technical level, which are the usual ones we have been dealing with all our life working on this area, right? And then we want to exploit, in this case, some knowledge representation, maybe to improve efficiency. For example, if I am transmitting, as before, the image from myself, to reconstruct the hologram of myself, then I have a blocking because I'm transmitting at millimeter waves and there is blocking. Then in a half a second, I could lose a huge amount of bits. But in principle, I can reconstruct all of them in half a second. What I'm doing and what I'm saying is easily reconstructible, reproducible. So it's another way to look at communications. Now, we can also have a distortion at the semantic level. Why? Because not necessarily the source and the destination share the same level of knowledge. The knowledge can be different. In practice, what can happen is that you might have deep neural networks in both sides, but they have been trained on different data. They might have different architectures and so on. This is why they are not necessarily aligned, as we say. Okay, so we want to deal with this. I could not refrain myself from using one equation, even though I should not do it. So I just put one, which is the information bottleneck, which is I think it's a fundamental principle, besides the mathematics. The point is that in every communication, I think the important point is to find a sort of trade-off between the complexity of knowledge representation and the distortion that we might have, given the complexity we want to use. The point here is that we want to measure this distortion in semantic terms. So, and in many cases, we transmit data X, but in most applications, we don't really care about X, but we want to take decisions based on X. This is why what we want to recover is possibly another variable, Y, which does not necessarily coincide with X, but it could be the output of a machine learning algorithm working on the data. So what really matters is to take the right decision based on what we have been able to receive. The question is, how can we quantify semantic distortion? In principle, we should ask humans to look at two videos, the transmitted one, the received one, they should say, okay, this is more or less the same, or images and so on. But of course, we cannot use humans, so what do we do? Well, nowadays it's typical to remove the human and put a deep neural network instead of the human. So we can define new KPIs, performance indicators, which have a semantic relevance. For example, we can use these LPIPs, feed, etc. These are well known in the computer vision area. And essentially what you do is the following. If you want to compare two images, instead of look at the images, you give these two images as input to a deep neural network that has been trained for classification, recognition, etc. And then you look at the latent space, what these neural networks produce in the last stages, and then you compare the latent representation instead of the original one. What's the key point here? The key point is that in principle you could have infinite different images, but they have the same semantic representation, which is the output of these neural networks. So in principle, you can have infinite different symbolic representations that have the same or very similar semantic content. Okay, once we have understood this, we can design our system based on these generative models. We want to discretize the models, because we still deeply believe in digital communication. There is some good principle behind digital communication, which goes behind the pure, physical layer. It's also a very good mechanism to control the overall network. So we want to keep relying on digital communications. This is why we did it digital. And let me go directly, so I will not go, of course, into the details of this, but just to mention an application. We want to transmit images, but we want to be able to adapt the transmission rate to the channel condition in order to preserve as much as possible the semantic content. How do we do it? For example, in applications like autonomous driving, you can say that typically in what you observe in your front camera, there are objects like pedestrians, cars, traffic lights, etc., that are more important than other objects like the sky, the trees, etc. So we want to incorporate this knowledge into the encoding, the image encoding process, and this is what we do here. Now, so we extract the semantic segmentation map. This can be done in real time. By the way, some Tesla cars already have the semantic segmentation algorithm working on the video taken from the front camera. And then based on this, semantic map, we design the encoder, and then we apply a masking, which is a way to adapt the transmission rate, but with a strong constraint of preserving as much as possible the objects that are more important than others in this application. This is why it's also task-oriented, because it's a task that says, in this case, pedestrians are more important than trees. Okay. Of course, the method can be applied to many cases. Then here we show some example. The top is ours. The bottom is the state-of-the-art in image coding, which is BPG. And then we can see that in our case, we are much better able to retain some, for example, there is some distant pedestrian here, but when you segment this image taken from BPG, you are not able to see the pedestrian there. You see no, in the segmentation, there's no pedestrian. In our case, you can do it. Okay, of course, there is a trade-off. The trade-off, there is no magic. Why let me show also some numerical results. Here we show, let's say, distortion versus rate. We have different measures of semantic distortion. And then we compare, in top, we have the JPEG 2000, and then we have BPG, and then we have a scheme based on deep neural networks, and then we have ours on the bottom. And then we can see that in terms of distortion versus rate, we can do much, much better. We can encode at 0.01 bit per pixel, which is, a strong reduction with a distortion which is much less than the competitive paths. Why is this happening? Because it looks magic. There's no magic here. The point is that while usual image coding schemes are universal in principle, in philosophy, our scheme is not universal. It's tailored to the application that is running on top of the communication. And we are really, relying upon the identification of the important points of the applications. Then, as I mentioned before, what are the problems that we might have at the semantic level? The alignment. What's the semantic alignment problem? It's the fact that, in these AI native networks that are coming, you might imagine that you have a lot of devices with parts of these neural networks split and distributed across networks. Now, since there are many operators running on the same, many hyperscalers, Nicola will say, running on this network, the networks that they have, they are not necessarily aligned. What does it mean? It means that those networks have been trained on different data sets, and maybe the companies don't want to give these data sets as open. Also, the architectures are not necessarily known to everyone. No, they're not. So the point is that if I am using part of this neural network to transmit, but I'm not sure about what is the receiver, what am I doing? I need to align this knowledge representation, which is given by the deep neural network. And then what we are doing here is semantic alignment. It can be shown that in some application, for example, this is an easy one. I want to transmit digits, and then this is the embedding in a two-dimensional space, and then you can see the 10 classes here. But then at the receiver, you have a different network, disaligned, which have a different representation. But the interesting point is that in many cases, not always, the disalignment can be recovered just by a linear transformation. In this case, a rotation will do most of the job, so that we can rely on this observation, very interesting, not given for free at the beginning. But then you can see that if instead of encoding those points in the latent space directly, but finding a relative representation of those points, actually we can send something and be able to realign the data. So we realign the data tuned to the receiver deep neural networks. Okay, and this is a pictorial example. So you can see on top what happens also when you have distortion, so some kind of additive noise. Then you see here, this is what happens with misalignment. So you recover something that reminds of the true image, but actually is not very good, even when there is no noise, essentially here. But then if we use the relative encoding that I mentioned before, you can actually realign these spaces, and you can get a fairly good image. Okay, I can wrap up so that we'll have time for discussion. So in conclusion, what I think is that we are evolving from a network of equipments to a network of intelligences. I on purpose wanted to use the plural, because these intelligences can be quite different from each other, and we need to take care of this. And of course, there are many challenges, essentially the energy consumption related to training these networks and the complexity. But for me, this is like a starting point. At some point, the networks will be the platform that will put together all these intelligences. So this is something that we have to deal with. Thank you for listening.
Questions for Sergio? I start with a general question. I mean, you showed the architecture and of the system and the semantic system, and as usually you show that we have noise at the physical layer, right? The transmission channel, but also noise at the semantic part because of this possibility to have some inconsistencies in the representation, right? My question is, I mean, you, of course, for representing information, you have a statistical component. In most of the cases, the noise that you have in the channel and the noise that you have at the semantic level are statistically independent, right? Is this the case, or, you know, I mean, where we can really gain and where we cannot?
Okay, this is a very good question, Antonio. And it gives me also the opportunity to, you know, to say something more. And the point is this, you know, we are so used to deal with information theory following Shannon, which is a theory essentially based on probability theory. Okay? But when we go to the semantic level, semantics is more governed by logical rules, which in principle are not random, are deterministic. Okay? So, for example, in this case, going to your question, in the physical layer, we deal the physical layer as it is today. So everything is exactly as today. Even the fact that we change the image encoder is controlled by the application layer that tells the source encoder. In fact, we don't touch the channel encoder. We are doing something different from the joint source channel coding, which has you know, its own problems.
Of course.
You see, it has its own problem. This is why we don't want to follow that path. You know, there are important works on the field, but this is you know, our approach. So we don't want to touch the channel encoder. We use the system only to say, given the noise that you have, your capacity is going to change, and then we adapt the rate, you know, to be below capacity, as Shannon taught to us. Okay, but in doing this, we adapt the rate using these mechanisms that are using, if you want, a redundancy, but redundancy is not only at the, you know, at the probabilistic level, let me say, but there is redundancy at the knowledge level. It's like when we talk to each other. There is a lot of redundancy, something that is there. We don't use it today, but we can.
Thank you. Other questions? Guido.
Thank you, Sergio, for your very interesting talk. I wanted to get back to a point that you mentioned at the beginning when you said there is an online part and offline part. Isn't the offline part the most critical, because in a certain way it's a form of communication?
Yeah. The formal, the offline part typically deals with a lot of a huge amount of communication taking place. But just because it is offline, you can do it whenever you want. Think of the, you know, stupid example I was doing of myself, you know, giving this talk, you know, and you have the hologram here. But what you need is to have a digital twin of Sergio. Today there's no digital twin, but one day maybe there will be, okay? That day, you only need to upload the digital twin whenever you want, one day before the talk, anytime. But then have it in digital twin. When I really transmit my talk, the real talk, I'm transmitting at a very low bit rate, because the rest is reproduced at the receiver time. Will not be identical to me, but you will see moving my hands as I am and saying the same things. So who cares if it's not exactly Sergio? It's the same.
Other questions? I didn't get any question from De Logione up there, right? So I want to have some questions from there. Please, don't be shy. Anyone? No? Here.
This is the backup from the floor. Okay.
De Logione can only throw tomatoes and potatoes if we don't do well.
Thank you, Sergio, for the nice talk. I'm interested in the task-oriented part. You mentioned this task-oriented part. Okay. Yes. So I was wondering if at the end, for the task-oriented semantic communication, you need different systems to optimize, because at the end, for example, for an image, there may be different interest, in what happens in an image. For someone can be interested to see, I don't know, if two cars crashes. For the other can be the color of a car, for example. No? Very different interest, very different task. So how do you deal with the different tasks? Do you need to build and optimize different semantic specialized systems, or can you do something different? For example, in your example of the avatar, I may be interested in understanding what is the color of your mustache. Just a very little detail, which is not your voice. How do you do with the different tasks?
Yeah. This is very, very key point. Thank you, Marco.
It's brown, by the way.
So first of all, we can also deal separately task-oriented and semantics. In principle, we can split them. So if we are only dealing with the task-oriented communications, the only difference with respect to today is that in the application layer, you need to specify the KPIs which are really important in the application you want to run. Okay, so if I am in an industrial setting and I send robots around to check how the machineries are working, if they're working properly or not, if there is a risk of some, breakdown, etc., then the robot will send the video to a server in the edge cloud. But what the edge cloud really needs is not to reproduce the video, but to be able to extract from the video a parameter that says, the probability that that machine is going to break in 1 hour. See, that becomes the new KPI at the application layer, which is completely different from the KPI that we will have today. Today we will say, how many packets do you receive correctly? It's not the real KPI at that level. Okay. Now going back to semantics and task-oriented communications. Even though in this talk I decided to focus more on the semantic aspect, but nevertheless the task-oriented part was somehow hidden in this formulation. Where was it hidden? It was hidden in the moment where I said, when I specify my KPIs, some of those KPIs are based on neural networks that take images and give you as the output the latent representation, the output results, etc. But you need to take into account that that neural network has been trained with an objective function. Now the task comes in the identification of the objective function. So in the example that I mentioned before, I'm interested in reconstructing objects and classifying objects, etc., all these things. This means that when I'm using those neural networks, I will use that objective function. But in principle, I could change it, and that would be task-oriented. See, so they go together in this sense, at least in what I've presented today.
Thank you. So let's thank Sergio again. So the next and last speaker for this session is Sara Mazzarella, Open Fiber. Another very interesting topic. When this one was, more, academic research oriented, very challenging, and this one is more industrial oriented. Another challenge, in particular, challenges for the digital transition in Italy, the copper switch off to enable a future-proof society. Sara, please.
Okay. Thank you, Antonio. Thank you to all of you. And I know that we are near the lunch time, and I don't want to annoy you, but talk about this important topic for us. And I want to start from an image and imaging of the Roman Forum that has been the heart of the political, religious, economic, and cultural life of the ancient Rome for thousands of years, and it has many monuments and temples under its underground. Imagine, for example, the fountain of Juturna, that is a small pool where Castor and Pollux, the legend says that they watered their horses. the lapis niger that is under a black marble, where the legend says the tomb of Romulus is hidden. Imagine the numerous temples, such as that one of Saturn and Vesta, the House of the Vestals, and many other temples or monuments. But now, imagine to go to Piazza Venezia and imagine to look at Piazza Venezia from the underground. What you see is another infrastructure that is such important as the Roman infrastructures, that is based on kilometers and kilometers of copper, old and worn out copper. An infrastructure that has been for decades the backbone of our communication, but now hinders our future and our digitalization, the digital revolution we are trying to put in place. I work as economist in Open Fiber. Open Fiber is a company born to deploy ultra broadband infrastructure towards Italy. And in Open Fiber, we are trying to experiencing the copper switch off. In fact, in Open Fiber, we are firmly convinced of the importance of the transition from copper to full fiber networks. And this is why we are convinced of the importance of recognizing your effort, the effort that the community of Restart has put in place to digitalize our country. In February 2025, Open Fiber launched a project that is called 100% Fibra Vera. That is a project where we are trying to cover with fiber networks and trying to switch off from copper to fiber networks. And these towns are Brolo in Sicily and Vedano all'Ambro, for example, near Milan. We are trying to drive the transition from copper to fiber networks, and with many goals, for example, to eliminate copper, but also to reduce the activation time of fiber networks, but also trying to raise awareness on the people about the importance of a future-proof connectivity. We are not planning a funeral, but we are trying to anticipate the date in which Italy is going to celebrate its promise to drive the digitalization of our country and the services that are that can be considered as future-proof services. But a question that is important for us today is who can benefit from it? Firstly, the environment. We are going to put in place a research with the Polytechnic of Turin with Michela Meo on the importance of the copper switch off that is related to the lower power consumption or the CO2 emissions, related to the lower number of network elements necessary to offer fiber services compared to copper services, but also the opportunity to recover the copper for other alternative usages. And finally, related to the importance, for example, to recover the buildings for alternative usages, for example, for creating new hospitals, new schools, infrastructures that are important for the people, for the society. Secondly, for telcos, because the switch off can be the key for example, for lowering capex and opex expenditures, or to improve the ARPU margin in the long run period, or offer other important services, for example, bundling with IPTV services and or video call and so on. Finally, for citizens and businesses, this is why people could have a greater quality of service, or could access to more digitalized services. But 2030, this is an important data. This is an important data because the EU Commission has decided to complete the digitalization of the European population, and ensuring that the 100% of the citizens have access to the fiber connectivity, to a gigabit connectivity. It is an important data also because it has been proposed as the data in which the copper switch off could be completed in all the European countries. But another question is, what's going wrong? Let me start with a question. Why should I pay for a full fiber connection? In Open Fiber, this is one of the most questions we get asked when we talk about the fiber benefits. This is why people don't really understand the importance of a fiber connection, and the answer is, nope, I'm good. When you think to the lady who wants to check her gas bill via email, or a gentleman who wants to review the latest restaurant he visited, or the grandson or the grandfather who wants to call his university grandson via WhatsApp. These are only few examples of the low impact of a future-proof connection for future-proof services, of the low importance of a fiber connection to have access to the services that we have as available today. But I want to share with you the elaboration I provided for you, starting from the results that have been published by the EU Commission a few days ago about the market panorama. Italy has made important steps in terms of fiber coverage during the last year, reaching the 70% of the market and locating itself ahead from the European average. But if we look at the fiber adoption, it is too much low. In fact, we have a fiber adoption that is equal to 25%. This confirms that people don't really care about the fiber opportunities, and that people don't really want a fiber connectivity service. And the gap, and it is a great paradox, because we have a gap, an enormous gap between the fiber coverage and the fiber adoption in Italy, but also in the rest of Europe. But if we go inside the market, the Italian market, and if we consider the fiber market share in Italy, we have that in the last 3 years we have had a transition from copper services to fiber services. In fact, if in 2021 we have the 40% of as a fiber market share, in 2024 we have a market share of 29%. The growth is stable and is positive, but it's too much slow. And if the growth rate is confirmed, the projections suggest that in 2030, the fiber market share will be at 60%. That is a market share that is well below the market share that is necessary to reach the European targets of a gigabit connectivity at the same data. Another question I have for you is, why should I dismantle a copper exchange? This is one of the questions that operators have when they think to the investments that they have to decide that have to put in place to drive the future-proof the deployment of fiber networks. And the answer is, it is not a profitable investment. If we focus on the dismantling strategies taken by the operators during the last years, what we can consider is that in the first years, the operators had decided to invest in the dismantling full copper exchanges, but they gradually decided to invest in hybrid exchanges, namely exchanges that are opened to ultra broadband services. This confirms that the operators are concentrated on technological and economical efficiency rather than on the general target to of the sustainability and the copper switch off. And this is the gap between the actual the state of the coverage with the hybrid and full copper exchanges. But so that what's the path forward? This is a call for action for all of us that are here today. For my colleagues in the industry, we must collaborate to not only to drive the deployment of fiber infrastructures, but also to raise awareness about the importance of a fiber connection and improving the services that are offered to the people on the fiber networks. To the institutions, we need the support to make people aware about the importance of a fiber connectivity society. For the policymakers, because we need a stable and a regulatory framework that has incentives for investing in fiber services and making people require these services. For academics, for all of you that are here today and that you are working to create a new society based on the evoluted services, continue on this way and try to create a killer application for a gigabit connectivity. And finally, for students, you have the future of the communication. Give us your ideas and your way of thinking to help us to build a future-proof society that is based on a future-proof infrastructure and that is going to give a greater availability of evoluted digital services. Okay, thank you.
Thank you, Sara. Questions?
Sarah, congratulations for your interesting presentation. Some years ago, I read a number that represents a ball chain in the diffusion of the in the uniform diffusion of the fiber. I read a cost of installing 1 kilometer of fiber in terms of 300,000 euros. So I read this number some years ago, but is it still this the amount to install 1 kilometer of fiber?
How much?
300,000 euros per kilometer.
I don't think it's
it decreased?
Yeah, I think it's not sustainable.
Okay. Because it's the number is that can you explain how much did it decrease?
Well, you must consider many things when you think about the deployment of a fiber infrastructure. The most sustainable technological tools that are available we are trying to use, for example, no-dig technologies and other technologies that can reduce so much the cost that we
about the problem of the fiber is not used. In my opinion, there is also a problem related to the quite average old age of the customers in Italy. Yeah. Indeed, for people, for the mid-age people more than 50 years old living maybe in a small village, the copper is enough.
Yeah.
Probably there is also a factor like this that hinders the usage of the fiber.
Yeah. When I talk about the awareness about on the importance of the fiber connectivity services for these people, for example, for old people, for my grandfather, is they understand that, for example, fiber is important in their homes to access to some services like telemedicine, for example. This is why I come from Macciaroli, that is in near Salerno, that is a small village where people can go to the hospital, and that they should have, if they had a fiber connectivity services in their homes, they could be assisted by their doctors, for example. This is not possible now. This is only one example. Yeah.
Thank you, Sara. Can you please expand the answer on the low adoption rate? When you ask the help of the regulators, what are you referring to? What are the main reasons for the low adoption rate beyond the laziness, let's say, of the customers? Are there specific also technical issues? For instance, the last vertical leg within the building, the way fiber is deployed in the building. So what are you asking specifically to regulators and to institutions from that point of view?
As a call for action, do you mean call for action for them? For example, I think they could define a final data for the fiber switch off, for the copper switch off, and define a regulatory framework, for example, for regulated tariffs, for example, they could make, or other choices as vouchers to people. During our experimentation in these small towns, we found that the opportunity to give vouchers to people to make their stimulate their fiber adoption is an essential element to run the path for a copper switch off. But you can have also, for example, providing services in bundling, for example, providing services such as Netflix. In Open Fiber, we are working with the University of Turin to simulate a model in which that simulate the progressive migration of the IPTV on internet, substantially on internet, and we are trying to understand what is going to be the future network and how the networks should be deployed and improved to favor the development of new digital services, for example, for streaming and IPTV.
Still no question from the Loggia. Ah, you have one. Go ahead, Davide.
Hello?
Yes, we can hear you.
Yes, thank you for your talk. So my question is about the safety aspect of switching from copper to fiber, because I used to live in the countryside and I burned many routers and computers due to lightning strikes that coupled in the telephone lines. Do you have any data or info about this? Is this relevant or just a fringe case?
The security, I enjoy your question because I didn't remember to talk about the benefits of a fiber connection in terms of security. We understand the importance of the security. For example, because we are following some decisions, resolutions that have been defined by the Italian Authority for Communication, which is trying to understand how the market could be opened. For example, the market of the modem, to make people have a greater opportunity to choose their equipment in their homes. And what we are trying to demonstrate to the authority is that the security is an important thing we should consider, and considering a network element outside from the network of the operator can be a problem for the society and for the security of the people, and also in terms of network neutrality of the people itself.
Great, thank you. Let's thank Sara again. So now we have the very important session dedicated to the demo and exhibition area for the project. So the area is on the other side of the building in this floor, so you can walk there. You cannot stay here. We will turn off the AC, right? You cannot stay here reading your emails. You have to go and give, a view on the project. They worked a lot for preparing the demos and the presentations. So go there, ask, interact with each other. Thank you. The lunch will be served not before 1:35, okay? And then we will come back here at 2:30 for starting the session dedicated to the panel on the future of telecommunications. Vittoria porta giù il microfono qui al desk. Grazie.